want me to do it?
Mama,
Must be
is
a
it
week
good?
or something.
This is too fancy.
What time's your flight?
Checked. We're live in color.
If you want me to do it, I'll do it. But let me know.
Good evening. How's the sound? Can you hear us in the back? Great. Okay. Welcome to this very exciting event at Bolen Books. Several months ago, I got this little book. Well, I got an email from Nathan, and then I said, hey, send me your book, and I finally got a hold of one. And I read the first chapter, and I immediately thought, Bob's going to love this book. Because it's a lovely book. It's so well written, and I'm not even a science person. So if I could make sense of it, I knew this was really going to help people. And so that's how this evening came about. Bob McDonald from CBC agreed to interview Nathan tonight and talk about this very fascinating book. And we just so appreciate you coming out and supporting not only a local author, but such a young author and such a great author who's, this is just the beginning, I think. So welcome to Bolen Books, welcome Bob McDonald, and welcome Nathan.
Well, thank you very much. Thank you for everyone for coming tonight. I'm delighted to come here. When I was given this book, it was, wow, that's amazing. How old is this kid? Wow, you're 16, correct?
Yes, not for much longer though. The brink is near.
Okay, good. Anyway, to have a book that could be a first-year astronomy textbook from a 16-year-old is remarkable.
I hate to say it, but no first-year astronomy textbook has that many puns in it. It can't be.
Which is why it is so readable. It's fun, but it's totally understandable. There are no mathematical formulas in it. It's a fun book to read, and thank you, Nathan, very much for doing this for us. Nathan has been touched in the head, and I don't mean that in a derogatory sense. He's been inspired by a vision of the universe, a vision that goes beyond what we see in our everyday lives. When you look outside and the ground is always down and solid, and the sky is always up, and the stars are always up. And he's got the vision that we live on a ball that's floating in an infinite blackness, roaming around an average star, racing around a Milky Way spiral galaxy that's part of an ever-expanding universe. And beyond that, he has the sense of awe and wonder. And the title of this book is perfect, Cosmic Wonder. And that's what he has done so well that he takes us on a journey through the cosmos, through time, through biology, through life, all the big questions that astronomers are asking. So this is a book that's readable for anyone. And Nathan, you did a really great job at bringing the cosmos to life. So I want to ask you my first question. When did that happen? When did you first get this sense of awe of the universe that inspired you to write the book?
Yeah, okay, so this allegedly began when I was 1 year old, actually, because according to fabled legend from my mother, I spent a great deal of my nursing time outside under the full moonlight. But the actual perspective for this book came when I was probably 12, watching the total lunar eclipse happen, and it was unusual because in this lunar eclipse, I was watching it through my telescope across the street from my house with a friend, and nothing much happened when I was looking, but when I was taking a little break to get a snack, I spin around and my friend shouts, "Whoa, did you see that?" Of course I hadn't because I was eating a cookie at the time, but regardless, he had seen a small flash on the moon's surface, and I didn't think much of it until the next day across the news headlines. Asteroid impacts the moon during lunar eclipse. And the scientists did a study on this asteroid, and it was like the size of a house, and it had created a crater the size of a city block, and it had released the energy of 55,000 kilograms of TNT. And I just thought, like, geez, if this thing had hit a city on Earth, it would have like leveled a skyscraper. Like the death toll would have been staggering. It would have been remembered forever as a tragedy. But because it hit the moon, like literally nobody saw it, except for a few people who were looking in the right direction at the right time. And I just thought, like, this stuff is happening everywhere all the time. And here we are on Earth eating our cookies, and something I like to do is just everyone here tonight take like a yoga breath with me. 3 seconds in, 3 seconds out. Ready? 3, 2, 1. And in the time it took you to do that, about 120,000 planets were just destroyed. Like, I'm talking Death Star style, like, gone. So that's the sort of perspective that really got ignited in me that night. Just, the universe is so much bigger than everything we can see. It boggles the mind.
And as the other famous book about astronomy, The Hitchhiker's Guide to the Galaxy, says at the beginning, the universe is big, really big. I mean, you wouldn't believe how unimaginably, mind-bogglingly big it really, well, you get the idea. It is. Now, how do you get a sense of that scale of just, it's so far beyond human scale, how do you grasp it?
Well, here's the really, really big secret. I don't. However, there are some analogies I like to keep in my head. First of all, there is no up or down. When someone comes up to me and is like, "Hey Nathan, what's up?" I'm like, I have no clue. That's a relative term. But I like to think there's more stars and planets in the observable universe than there are grains of sand on all the beaches and deserts in our planet combined. If the size ratio between a water molecule and the Earth is the same as the size ratio between the Earth and our supergalactic cluster. So we are in the middle of just an absurdly vast cosmos that extends to infinity in both directions. So I'm hesitant to say that I can grasp it. I think that's a stretch. But there's things we can picture in human terms that can give us some inkling of an ounce of comprehension of the absurdity of the universe. And that's part of what I hope to do in my book. I don't think it's possible to comprehend it. I have never come close. But it is possible to imagine.
Well, you're certainly heading in the right direction. You're certainly heading in the right direction. If you don't mind me telling a little anecdote from a much earlier book that I did called Measuring the Earth with a Stick, I wrote a chapter about the night I almost fell off the Earth. And I was in Africa, in Tanzania, just below the equator. And I went out late at night, and I was on the East African Rift Valley, which is one of the largest valleys on Earth. And I got away from the place where I was staying, away from the lights, and lay on my back on the hill. And the Milky Way was straight overhead this way. And under the dark African skies, it went all the way down to the horizon. And because I was on a hill, the sky was in front of me, not up. And I began to realize that I was on the side of the Earth, not up top like we are here in Canada. I was on the side. And because I was on a hill, I started digging my fingers into the grass to hang on. And then I started thinking about the direction that the Earth was moving through space at that moment as we go around the sun at 30 kilometers every second. And at that hour, when I worked it all out, I was looking out the back window of the Earth. And I thought, holy smokes, if I let go, I'm going to be left dangling out in space while the Earth rusts off behind me. I was a fly on the wall. And I wasn't smoking anything. That's the kind of perspective you get, right?
It's really relatable. Like when I'm walking with someone and then they, like at night, and then they say to me, "Hey, my eyes are down here, you know?" And I'm like, "Oh, I'm sorry, I promise I wasn't looking there." And then when they say like, "Do you think we're moving too fast?" And I'm like, "Yeah, we are. Moving at 600 kilometers a second through the galaxy right now." It's something that just is easy to forget about. It's very easy to forget about, and it's probably healthy to forget about, if I'm to be honest. But it is just that sense of awe you get when you realize that when you look out into the sky and you see the Milky Way, you're looking forward in the galaxy, not up, and you're just like pinned to the wall of a massive sphere. Yeah, that's relatable.
Massive pinwheel is carrying us around this way. So in your book, you do talk about the size of the universe and also the end of the universe. Since it's expanding now, it has a couple of possible fates, but you also talk about infinity. It could be infinitely large. And I have trouble with the word infinity. To me, that's scientific lingo for, I don't know, that's the limit of our knowledge. So how do you cope with that whole concept that the universe might be infinite, even though we can't see it all?
Well, what you said about the end of the universe, that's a tough one to grapple with. I did a research project on this a year and a half ago, and then I was like, how do I explain this to the kids? Because like the little like preschoolers were coming in, and I was like, yes, kids, we are all going to die one day, and our entire history of our civilization will be erased. Have a nice sleep tonight. But the concept of infinity, that's a big one, because when you add in infinity, a whole bunch of weird things happen. When you think about the universe being infinite in size, it becomes inevitable that there's another copy of us out there, an infinite number of copies of us actually, doing this exact same thing over and over and over again. And if the universe goes on forever in time, then it also becomes inevitable that this will happen again in the future. So the thing about infinity is anything times infinity is infinity. So when you bring up the concept of infinities, it's strange, but the current theories of the universe predict that it's real. And I think that's sort of the awe that cosmic wonder gives, because it's something that our minds were never evolved to comprehend. Infinity, that's a strange idea, but it could be real.
So's the idea that there could be other versions of us doing exactly this at the same time, or again in the future.
And there's one where the Death Star blows up our planet right now. Glad it wasn't this universe, but...
And then there's the other possible end of the universe where everything just rips apart and we go into infinite darkness and kind of a sad ending.
There's three possible endings of the universe. The first is gravity pulls everything back together and everything in the cosmos gets a nice hug cataclysmically as everything collapses into a black hole. Then there's the rip, where everything gets torn apart right down to its very atoms. And then there's just the slow fade to black afterwards. There's also one called vacuum decay, which is like space itself collapses. So it's not things expanding in space, it's like literally space itself breaks down. That one's kind of scary because it breaks down at the speed of light, and you know what else travels at the speed of light is light. So you have no way to see it coming. Could be 5 seconds away for all I care, but I'm going to assume it's not.
Thank you. Have you read the Isaac Asimov story about the greatest computer, the ultimate artificial intelligence that had all the knowledge of all the civilizations in the galaxy, and it could answer any question at all? And the daughter of one of the operators of the computer was doing a school project and asked her parent, "What makes the stars shine?" And the parent explained, "Well, they're big balls of hydrogen, and the pressure of gravity squeezes it into helium, and there's fusion, and that gives energy and light." And says, "Well, will they burn forever?" He said, "No, actually, the sun's going to go out." "Will all the stars go out?" "Yep, eventually all the stars are going to go out, and the universe is going to be completely black." And she goes, "That's kind of sad. What'll make the stars come back on again?" And he said, "I don't know. Let's ask the computer." So they put in the question, what would cause the spontaneous regeneration of stellar matter, something like that. And the computer comes back and says, "Not enough data." And it becomes the first question the computer cannot answer. So it's still thinking about it. Meanwhile, the universe gets old, stars start going out, and the universe is coming to an end. And when the final star winks out and the universe is cast into infinite darkness, the computer comes up with the answer. But there's no one to tell. So it says, "Let there be light." And there was light. Great story by Isaac Asimov. Anyway, let's get back to, let's go the other way, about the beginning of the universe, the Big Bang. I was interviewing a scientist who studies cosmology, and he said that he studied the Big Bang. He was explaining this to his mother, and his mother asked him, "What went bang?" And he couldn't answer. What do you think went bang 13.8 billion years ago that ended up being us sitting here talking about it?
I know what it is.
Right, so there's a lot of theories about that, what caused the Big Bang to bang. This is part of a long-lasting question that I have sought to answer. It's a common childhood question. It's, where do babies come from? But in the broader sense. The biggest picture possible. Where do babies come from? The Big Bang. But regardless, what made the bang go bang? It's one of the theories by the cosmologist, I can't recall his name at the moment. However, his theory was that space has always existed in some form, but it was expanding at an absurdly fast speed in something called like cosmological inflation. And this inflation happens so fast, this space expanding so fast, that you'd like take 2 points a blueberry's width apart, and it expands to the size of our Milky Way galaxy in less time than it takes a beam of light to cross the width of a human hair. That's obviously too fast a little bit for anything exciting to happen like planets and stars and life, but such space expanding so fast has like an absurd amount of energy in it, and anything with a lot of energy, anything in this universe with a lot of energy wants to get rid of that energy. If I drop the mic, which I won't because I didn't just finish a rap song, that's gonna like release the gravitational potential energy in the microphone. And same with space. Space eventually released the absurd amount of expansion energy it had in it. So space slowed down all of a sudden. But it released all that energy, and it's kind of like throwing a boulder off a cliff, releasing all that energy. The boulder doesn't just land and then quietly just sink in. It's gonna make quite a splash. And so what ended up happening, based on this theory, is that space slowed down, and all that energy stored in the expansion of space got converted into heat, which then exploded into a huge bath of particles that eventually became you and me and everything around us. So in the broadest sense, where babies come from is a reconfiguration of the energy of the expansion of space itself, which is not taught in sex ed, but I feel like it's an awe-inspiring answer.
What about before the Big Bang?
If you know, I have a lot of questions for you, but based on that model, what came before the Big Bang is still this infinite expanding region of space where not only our universe, but infinitely many universes are just constantly popping into existence as space slows down in little pockets everywhere. And we have no way to reach those little pockets, but they're always collapsing everywhere, basically. And so every second of every day, there's trillions of new universes just appearing everywhere, and it always has been and it always will be. That's one interpretation. I'm sure there'll be many more discovered in the future. That's the one that I take at the moment, though.
Depending on what universe you live in. I think of it like soap suds. You got all these little tiny bubbles, and then every now and then one of them gets big. We're in a big one right now, and you can't go to the other bubbles. We just don't know how to do that yet, but that's another idea. Okay, so where else do I want to go here? Your book was great, thank you. By the way, he mentioned the lunar eclipse that happened here a few years ago. I was up on Saanich Mountain at the center of the universe, where we have our big telescope. That was the largest in the world when it opened, by the way, the largest operating in the telescope. It's over 100 years old, and Nathan is now working with us up there on star party nights, which we just began this last weekend and are going to be now continuing throughout the summer. So invite you to come up.
Astronomy is the only profession I've ever seen up at that observatory that has a bed and blanket in the middle of the workplace.
Okay. So we also talk about alien life. What's your take on that?
I think that alien life is everywhere. Personally, I'm kind of like the believer of sorts. Just to take a statistic, the fact that there's more planets and stars in the universe than there are grains of sand on all the beaches on Earth combined, and the fact that if the universe is infinite, this is not even a question, there's guaranteed to be life out there, but even within our finite region of the universe, I think when we look beyond the sort of narrow scope of alien life that is sort of popularized in science fiction, like the green people, basically, is like the common notion of extraterrestrials. But when you expand this definition to the whole scope of the possibilities of life in the universe, we live on a planet where most life is made up of water and carbon. In fact, all life is. It's just the two fundamental ingredients for life on Earth. You have water to mix chemicals in, and you have carbon to hold it all together. It's pretty good on Earth. But elsewhere in the universe, you could have other chemicals that could potentially hold living structures too, like on Titan, a moon of Saturn, where instead of water and carbon, it's 180 degrees colder, so if you tried to use water and carbon, you'd just get a solid rock, like ice. It's like Winnipeg temperatures. Mine is 180 degrees Celsius, but on Titan, that's just the right temperature for methane and nitrogen. to be the liquid components that you use for building blocks of life. So could you have those compounds for living creatures on Titan instead? If you had living creatures on Titan looking for extraterrestrial life, they'd probably think that the Earth was way too hot for any life to form. They would think that it was covered in toxic oxygen and an ocean of molten ice. Deadly. But there's even more possibilities. You could have beings of life made of silicone, because silicone bonds the same way as carbon does. Silicone only works at temperatures of thousands of degrees, though. So something I like to imagine is if carbon can bond to make life at room temperature, and silicone bonds the same way that carbon does, but it bonds at thousands of degrees, could you imagine living systems in molten silicone deep beneath the Earth's crust in the mantle, made of silicone, with no idea that we exist, we have no idea that they exist, just two completely different biospheres, one on top of the other, completely disconnected. That's like borderline science fiction, but it's just something that I like to imagine.
The Earth is alive, in other words.
Absolutely.
Yeah, one of the things that bothers me in science fiction is that, like in Star Trek, whenever they land on a planet, all the aliens speak English. And they look like us. They got one head, two arms, two legs, and they're not going to look like that. They're going to look totally, totally different. And the possibilities are infinite. Right. Just a couple more questions before we'll open it up to you. There's a few thinking questions I want to hear from you. But we have a little bit of an embarrassment in astronomy right now, and that's the fact that 95% of the universe is dark matter, and dark energy. And again, the word dark is a scientific term for I don't know. So we don't know what 95% of the universe is made of. Does that bother you?
I mean, in the 1600s, we had no idea that there were other planets out there, and they nailed people to stakes and set them on fire for saying otherwise. So the question of whether it bothers me, I think the fact that we have like the freedom to contemplate that is wonderful. And I think that there's always the chance that tomorrow will be the day that we know what it is finally, because in the year 1900, the physicist Lord Kelvin was kind of infamously quoted for saying, "Nothing new is to be discovered in physics now. All that remains is more and more precise measurement." This is 1900. This was before Einstein, Schrodinger. This was before black holes. This was before quantum physics. This was before relativity. This was before a lot of stuff happened. So when I think about what's about to happen in this century, dark matter and dark energy may not be dark for much longer. And the fact that we don't know what they are today, I think, is just inspiring to me. The fact that we still have so much more to discover. It keeps us curious. It keeps us looking up. It reminds us that we haven't got it all figured out yet. And if you have checked the news lately, we have not got it all figured out yet. So it keeps me hopeful that we're going to keep looking for new and exciting things in this universe. We're not done yet.
Well, dark energy and dark matter were discovered within, not just within my life, within my career. So it'll be within your lifetime and career that we'll figure that stuff out. My last question for you is what's your message? What's your message?
I think the big message of Cosmic Wonder is just stay curious and try seeing things from a new point of view. Because this civilization, we've created abstractions that do help us categorize things, but also lead to these sort of artificial lines drawn between people and land that isn't actually there. Like, we've waged wars over like lines we've drawn on maps. We've categorized people based on the wavelength of light that the atoms in their skin reflect. Like, what the heck? So I think when you see people for a bunch of atoms, rather than a religion, a culture, a nationality, it really, really like erases those lines we've developed between us. Like, when you think about the fact that 99% of the universe can be created with just 5 different elements, there's 118 elements we know of. Just 5 of them you can already build 99% of everything out there. Us, this store, the earth, the stars. So how different are we really? And as for seeing things from a new point of view, staying curious, I like to look at the wooden boards down there. I could tell you, if I looked close enough, what the temperature of the summer and winter of each year in that tree's life was. It gets a bit existential at times, but there's a lot of cosmic wonder just everywhere around you, and I think taking a moment to pause and look at it is fascinating. When you turn on a television and you can't find the channel you want to look for, but you just see a static screen, take a moment to look at that, because the static you see on an untuned television screen is mostly the microwave radiation left over from the Big Bang itself, coasting through space right into your antenna. So have a listen to the first official music album ever broadcast in the universe. The message of my book is really just keep looking up, because we have such an amazing potential for a future as a species. And as long as we keep looking out to where we could be, I think that will keep us going. That's what kept me going. That's what keeps me going to this day. Just the amazing potential for our future.
Nathan, Thank
Thank you so much.
Wow. Okay, so question right here in the front. Yes, sir.
This is not a question, it's, and I'm Nathan's mom's uncle.
He's my great uncle.
Great uncle. And chronologically, you'll have to help me out here, but you wrote a little book, a love story of two sperm among a lot of sperm. and how the beginning of a life starts.
I have been a nerd for my entire life, guys.
Yeah, so help me with do you know when you wrote that?
I was 7 years old when I wrote that.
Okay, so he wrote that when he was 7 years old, and I thought I'll be very clever with him, and I said, Nathan, do you think there are other living people like us out in the universe? And that's when he said to me, well, I said, because the universe is infinite. And he was 7, and he said the story that unfortunately he got to before I did early in his talk is that, well, that depends on whether the universe is infinite or not. And I looked at him and I didn't expect that answer. And he said, but if it is infinite, then yeah, there'll be an infinite number of planets out there that will support Earth. He was 7. So that's just a kind of a background story.
Thank you very much. Question in the center there, yes, sir. Speak loud so I can hear you.
What is your current level of formal education?
What's your current level of education?
I'm chilling at Mount Douglas Secondary School, grade 11. It's been lit. Hi, Eli. I gotta get my side. Ready to the race.
All right. Yes.
What is your opinion on like the new theory of wobbly gravity?
The theory of wobbly gravity.
I'm gonna have to read more about that. Teach me
too.
about that, please.
It's a theory that rather than, I believe, dark energy influencing gravity, gravity itself is just not constant, given its positions.
Oh, is this the theory of like Mond?
Yeah.
Yeah, okay, that's interesting. I have been reading about that for a while, and I have no idea. But that's interesting that one of the constants of our universe that we believe to be constant could vary on large scales. That's one of the sad things about being limited to the observable universe. I would never say that the observable universe is small. I mean, heck, it's 46 billion light years in all directions. But if the universe is infinite, it is still 0% of everything out there. And so scientifically, that's a very small sample size to be working with. So even the constants that we believe are constant within our universe could change over large distances that we just can't fathom within our tiny speck of an observable universe. Everything is just a speck of dust.
Okay. And that goes along with figuring out dark energy, which is pushing against gravity. Okay. Any other questions? Yes, sir. Right here.
One of the people who's been renowned through his life as an explorer of sorts is William Shatner. Now, I don't know whether you know who William Shatner is because you're pretty young, but he's somewhat famous. But he recently had an experience when he went up through the Earth's atmosphere on a spacecraft that Jeff Bezos had set up for him. And it really shook him and made him I think, finally come to a view, some kind of cosmic wonder view. And I don't know whether you're aware of how he felt about that. He felt so alone, and the Earth was so vulnerable.
Is this the Star Trek person?
Yes.
Okay, yes. Yes.
Yeah, so the question is about.
How do you relate to that?
Yeah, the question is about William Shatner, Captain Kirk. He got a free ride on Jeff Bezos' space tourism rocket that goes up just above the atmosphere. You get about 5 minutes of weightlessness, then come back down. And when he came back, he was in tears because he saw the thin line of the Earth's atmosphere and realized that's all we have. And it really shook him up. So
I think he really developed a pro-environmental stance after that, and I definitely want to support that. And I have a section written about just how fragile the Earth's climate is in my book. And I am such a hypocrite for writing a book about that, mentioning deforestation. I'm like, trees are being cut down. Let's cut down trees and publish a book on it. Am I right?
We'll recycle.
Yeah, when you're done with this, please recycle. Thank you. But I think the stance he has and my feelings on writing this book have the common thread of just seeing our planet as the pale blue dot in the world. In the words of Carl Sagan. Carl Sagan has been a personal hero of mine my entire life, and his vision of the pale blue dot has resonated with me forever, basically. Just the notion that everything we will ever do on this planet can be summarized with just a blue speck. And that's really powerful, because when you ask yourself what matters, it gets easy to read this and get completely nihilistic. That's what I got. But I wouldn't say that nothing matters, because meaning is a product of these brains. Because without these brains, there is no meaning at all. And when you think about this planet as being a planet that has trillions of brains on it, animals, humans alike, then this planet is really just a little island of meaning in a cosmos that has no concept of meaning whatsoever. So all the meaning in the universe is right here on Earth and any other planet that happens to harbor sentient life. So I think the Earth really does matter in that sense, because the very beings that can conceptualize what meaning is live on it.
and it's all we've got. Yes, ma'am.
The thing that's driven me crazy my entire life when I give into thinking about it is, if the universe started and the universe is everything, how can there be a before? And if it stops, how can there be an after? Because it's everything. And how can you have space before everything? And how can space expand when the universe is everything? And how can time expand when the universe is everything? So it's driven me crazy. What's on the other side?
Okay, so the question is, if the universe is everything, how can there be a before? And how can it expand into space if there was no space? And how can there be a nothing afterwards if the universe is everything?
There's some theories about that. One of them is that our universe will one day grow cold and dark, but there will still be a tiny amount of residual energy left over, and unimaginably far in the future, that may just snap one day and trigger a new Big Bang. And in that sense, our own universe may have been born from that little cosmic trigger, quantum snap, in a much older dead universe, and it's just a cycle that keeps going full circle. And that's kind of mind-boggling, because that opens the possibility to there being trillions of stars and planets and galaxies before our universe ever existed. Perhaps we're in the middle of an infinite cycle of universes. If the universe one day crunches down under gravity again, it might not just crunch down into nothing, it might bounce. So getting smaller and smaller, then it hits the center, and then it goes out again in another Big Bang. So there could just be Big Bang after Big Bang after Big Bang. Anything could have happened in the universes in the past. Maybe you guys have already bought a copy of my book and read it, in which case no refunds. But it's really just, we are in the middle of nowhere, but in the sense that our universe could have a before, what comes before that? Maybe it was another universe. Who knows?
Yeah. The questions you're asking are at the fundamental basis of our knowledge. And that's why the largest experiment on Earth right now, the Large Hadron Collider, is trying to create those conditions of the Big Bang to figure out what the heck was going on there. Because everything that existed back then does not exist now. It was pure energy. And so it's very difficult to know that. And the other thing, when you talk about space, the universe did not evolve into a bigger space. Space itself expanded. It stretched out.
Into what?
Einstein showed us that space is flexible. It didn't go into anything. It is everything. But again, these are mind-boggling ideas that go beyond our convention. Any other questions? Yes, sir.
For somebody as talented as you appear to be, where do you see yourself in 20 years' time?
Where do you see yourself in 20 years' time?
I feel like I will still be asking myself, where do I see myself in 20 years' time? But I have a few plans. I would love to study astronomy, as part of it, at least. Oh, this is the question that has haunted me for like 5 years. But I'll get back to you on that in 20 years.
I'm going to lose my job, is what's going to happen.
I'll have lost my hearing.
Another question at the back there. Yes, sir. Yep.
You mentioned, I think there was some mention of science fiction. I was wondering whether you read science fiction or you have an interest in writing science fiction at all?
Do you have an interest in science fiction, either reading it or writing it?
Isaac Asimov for life, guys. It's, I read. And Douglas Adams, absolutely. At the moment, I am working my way through the Hitchhiker's Guide series.
Good. All right, just one more, yeah?
I always wondered about how the infinite boundaries of the universe sort of begets in infinite possibilities. But I wondered how that deals with the possibility of there being infinite empty space rather than identical copies of us.
So could there be infinite empty space rather than infinite copies of ourselves?
This gets back to the notion of infinity. I like to compare it to a lottery, with us being the cosmic lottery, something extremely unlikely. If you want to win the lottery and you buy one ticket, your odds are like 1 in 20 million. If you buy 20 million tickets, your odds are pretty darn good. If you buy infinite tickets, you're guaranteed to win infinitely many times. And so the point is, if the universe is infinite, there is infinite empty space, but also an infinite amount of everything else, because infinity is not your ordinary addition. This is like next level addition, because infinity plus infinity is still infinite. You can't take anything away or add anything to infinity and get anything but infinity.
Which is why I hate it.
It's a tricky concept. I could talk forever about this.
I want to leave you with a little connection. I'm feeling a sense of deja vu here because of his age and the fact that this is written by a young person. If you know any young people, give them this. Because when you are inspired, as Nathan is at his age, you stay that way for life. I was inspired when I was 6 years old, when my mother gave me this book called The Planets, Golden Library of Knowledge. I didn't know anything about planets, but this book told me that the Earth is only one of a family of planets and the others are really, really different. So at 6 years old, I knew about the solar system. And it has been an exquisite pleasure to grow up and become a journalist during the time when we went to those planets. And I was there at the Jet Propulsion Laboratory when we first went to Mars and Jupiter and Saturn and Uranus and Neptune and Pluto and watched these pictures come in for the first time. So this book came to life for me, but I was inspired as a kid to get interested in space, and it's still with me today. And the other thing I thought you'd find just kind of funny, I went into an old photo album and I dug up that. I don't know if you can see it. That's me with Nathan's length of hair, teaching at the Ontario Science Centre, teaching astronomy.
Let's go.
At the Ontario Science Centre in 1977. So, a lot of parallels. Nathan, thank you so much and good luck with your book. And thank you all for coming here tonight. Thank you.
Take more questions at the signing booth if you have any.
So Thank you. That was so good, you guys. And honestly, you read so much about how kids' brains are being stifled by technology and phones. And it is so thrilling to see so many kids here tonight who are just excited about learning and understanding things like the universe. So thank you. It's been so inspirational. What we're going to do now is Bob and Nathan are going to sit at the signing table. If we're going to line up down this little walkway. So if you have a book, if you've purchased a book already, or if you want to buy a book and get them signed, you can just line up and you can get Nathan to sign a book, and then you can go purchase it at the tills.
And I have a book too.
And if you want Bob's book, they're also on the table. So that's how this is going to go. And thank you all so much. And thank you so much, Bob, for coming to do this. And thank you, Nathan, for writing this fantastic book.
Reminds me of, there's a Monty Python skit on you can watch on YouTube where he's interviewing Mark